Welcome to the National Institute of Neurological Disorders and Stroke Advisory Council meeting for September 2021. I'm Dr. Walter Koroshetz, pleased to give you the director's report. First, I want to talk about some leadership changes going on at NIH. Dr. Michael Gottesman, after 28 years of service in the role as the head of the intramural program, is stepping down, and NIH is launching a nationwide search for his replacement. Marie Bernard, who was the deputy director at the National Institute of Aging, was named the NIH Chief Officer for Science Workforce Diversity. And Chris Austin, a neurologist who is running the National Center for Advancing Translational Sciences, has left NIH, stepped down, and Joni Rutter is now serving as the acting director. At NINDS, we're really pleased that Marianne Sofranco has been appointed as the NINDS Executive Officer. She joined NIH in 1997. She joined NINDS in 2009 as a Deputy Executive Officer, and she served as the Acting Executive Officer on 2 occasions. She's expert in administrative management, complex personnel issues, and an advocate for disability hiring. We're really lucky to have Marianne working for us. Thanks so much, Marianne. As I usually do, I start off with a picture of the budget. And I can show you here in 2018, 19, 2020, 2021. But for 2022, which is what we're going to be talking about today, we don't have a budget yet. And so we're operating under 3 possibilities. One is a continuing resolution in which we are operating now, actually, and that's a 0% increase from last year. The House mark is 6.2% increase, and the president's budget is a 5.4% increase. And we don't know which of these we're going to get at this point, so we have to prepare for the worst case scenario. And I should say that these numbers here in this row do not include money for the HEAL initiative, the BRAIN initiative, or the Cures Act, although there is an increase which is in our base that's targeted for pain research that's outside of HEAL, and that's about $42 million. Now, if one looks at the funding, including BRAIN, including the Cures Act money, which goes to BRAIN, including the HEAL initiative money, one can see that under both the president's budget and the House mark, there is a significant increase, over 10% on the president's budget to NINDS. And note that both the president's budget and the House budget includes $43 million for pain research in our base budget, and that's outside of the increase that comes to the HEAL initiative. Looking towards 2022, we would be extremely tight if we got a continuing resolution throughout the year. In fact, we'd be about $24.7 million short, and we'd have to make that up either by trimming non-competing or not investing in, programs, HPPs, high program priority grants, or bridges, supplements. We'd have to find a way to make up for about $24 million. If we do get the president's budget, we think we can definitely hold the 14th percentile. And remember that this includes, of the increase in the president's budget, about 40% of it is targeted for pain research. Now, the reason the pay line is not moving is primarily because the number of applications is going up. As you can see here, between 19, 20, and 21, we see a steady rise in applications. So the percentile scores, the denominator is the number of applications, and also the cost of grants has gone up. As you can see here, 18, 19, 20, 21, the cost of the average grant is going up each year, and it's an increase, considerable increase between 20 and 21. and it's primarily driven by the increase in the non-modular cost of grants. Now, I want to point out that when it looks at cost, one has to think about inflation. And Michael Lauer did this very interesting analysis, which will be coming out in a publication at some point, looking at the cost of grants in the yearly numbers that we report out here in the pink line, but then adjusted for bird pie, which means the biomedical research price index, like the inflation rate for biomedical research. What you can see here that if you normalize to inflation, during the doubling, there was a big increase in the cost of grants, the mean cost of grants, and then it came down. And during that flattening, it was pretty flat, and then it started to go a little bit up, and we're just seeing a slight increase now in the last couple of years since our budget's improved. But in actual fact, we're basically, in terms of real dollars, in terms of inflation-adjusted dollars, we're right now where we are in 2020, same place we were in 1995. So this increase is really constant with what one might expect with inflation. What has changed is the number percent of solicited projects and their funding. During the period of the doubling, there were more and more solicited projects. And then they kind of flattened out during those lean years, but now they're starting to go up again. And similarly, the cost of these solicited projects, the funding that goes to these solicited projects is actually going up pretty high, almost to 50% of the NIH budget. And for us, these solicited projects are Brain Initiative, Heal Initiative, Alzheimer's disease-related dementia, pain targeted funding. So all the targeted funding is driving up this amount of money going to what's called solicited funding, as opposed to pure investigator-initiated, not in response to a particular RFA. I want to talk a little bit about the breakdown now between the different aspects of our portfolio, the basic being research that's uncovering mysteries of the fundamental workings of the nervous system, that's disease agnostic. Basic disease research is basic mechanistic research about disease mechanisms. Applied translational is research that's going towards development of therapies. Applied clinical is testing clinical interventions in patients. And as people may remember, there was this very sharp decline in our basic research, fundamental neuroscience research. And we did a bunch of things to try to stop that, which was successful. We were able to prevent the drop. And since then, we've been pretty much flat with some increase occurring more recently. The decline in the basic research was basically driven heavily also by the increase in basic mechanisms of disease research that occurred as better tools for disease research appeared. This is our clinical research, which is actually a little lower than what we've seen in the past, and our translational research programs, which are now quite robust, but still, small percentage of our research, which is mostly basic research. Just shown here, blown up, you can see that we're pretty much flat in terms of the basic research, slight increase in translational lately, slight decrease in clinical. Important to note is that the Brain Initiative has really been heavily on the basic research side. And so if you look at all our research here in the green box, and you take away the brain research, you see the same general patterns, although the basic research now is depressed compared to what it is with Brain Initiative. And the disease basic research is elevated because most of the brain, there's some brain research that's disease related, some clinical, some translational, but the majority of it is basic research. So we've kind of challenged the program directors to try to think about what are we missing in terms of the mechanisms or the research resources or opportunities that we could put in play to advance fundamental neuroscience research. And there's a group that's actively analyzing, looking for suggestions, and they'll be holding workshops and getting input from the scientific community to see what we can do to foster and catalyze and prioritize opportunities to advance fundamental knowledge of the nervous system, which is really the foundation for all we do. So if people have suggestions, please send them in. Bob Riddle is leading the group. Lynn Jakeman, the Division Director for Division of Neuroscience, also leading this group. I want to take this opportunity to thank the staff at NINDS who've been really working extremely hard in challenging situations, working at home during a public health emergency. They've been able to handle bigger budgets, more applications, more total grants, issued more funding opportunities, held lots of meetings, and managed clearly every year new administrative requirements. I want to thank them for helping us and NINDS really not really lose a step in the work that we do in funding research around the country. I want to now point out this really amazing program that Shai Silverberg and Devin Corford are leading. As you know, NINDS has taken a leadership role in trying to improve the rigor of experimental design and experimental analysis. And this is the next step, and it's an ambitious one. We're going to be looking to fund groups that will develop educational materials that will improve experimental rigor. This could be targeted trainees, but I think all laboratories could probably benefit. Just as we physicians do continuing medical education every year, this would be kind of the equivalent for basic laboratory research. And also creating a coordinating center that would validate and test these educational materials and then try and disseminate it through our champions of rigor around the country. So the applications are due October 21st. So please talk this up and see if we can get some really interesting and helpful education materials through this application process. I wanted to mention in the president's budget, there is funding for a new agency called the Advanced Research Project Agency within NIH. I think that's most likely where it will end up. It's called ARPA-H. It's thought to be a parallel to the Advanced Research Project Agency in the DoD called DARPA. And they operate differently than we do in current NIH mechanisms. It's much more top-down. There's the group that runs it, decides on which projects are high priority. The program directors are really heavily managing these projects. They do call for applications. The funding goes out quickly. The funding is moved from one project to another or from one group to another, depending on the success rates. And it's able to produce some amazing results over 2 or 3 years of funding. We worked, for instance, with a DARPA arm. It was a prosthetic arm built by DARPA. Had amazing digital control, and we, with DARPA, made it available to our researchers to develop interfaces. So these kind of projects have been shown to work well in the DARPA system. And now the question is, what would ARPA-H look like? And so this is being put together by folks in the White House at this point. And there have been listening tours, one last couple of weeks ago on neuroscience. And if people have ideas on what kind of projects they think that should be tackled in this kind of more of a top-down managed mechanism, please let us know. I'd be happy to pass those along to the people in OSTP. So what are the intractable problems that ARPA-H may be best able to move on? How do you see your communities engaging with these opportunities? Hard to answer what challenges you foresee, not knowing what it looks like. But if you've had experience with DARPA, there might be something there. We've talked in the past about the post-acute sequelae of COVID, which have a large neurological component with fatigue, inability to process information quickly, make decisions quickly. People in the public venues call it brain fog. Trouble with sleep, headaches, pain syndromes are really the most predominant troubles affecting folks after they've had COVID. And unfortunately, even people who were never hospitalized, certainly worse in those who were hospitalized. But the big surprise was this is occurring in people who were never hospitalized. So this program, which is appropriated $1.15 billion by Congress to try and understand the biological causes and hopefully treatments for this condition, is launching now. We have data centers, coordinating centers. We have cohorts that will enroll up to 15,000 people and follow them over time. Some of them infected with COVID now, and then following how they recover. Others infected in the past, and trying to understand how people with persistent symptoms differ from those who have made a full recovery. We have electronic health record studies that will be able to follow millions of people over time who've had COVID, see what type of medical problems come up over time. And then also autopsy studies to try and look and see, is there virus still present in the brain, or is there evidence of autoimmune attack in different organs? So this is a very ambitious program, moving quickly. Hopefully we'll get answers fast enough to test them in clinical trials to improve outcomes. Another major public-private partnership we're involved in is called the Accelerated Medicine Partnership, with multiple different groups, including Michael J. Fox and ASAP. Akemini works with ASAP and can talk to you about it. Also multiple industry partners. And this was put together and is run by Deb Babcock in NINDS. And the plan initially was to harmonize clinical and biomarker data from thousands of patients with Parkinson's disease. And it's really been quite amazing to see what has been produced. There have been 8 cohorts with thousands of participants now. They come from NIH-funded projects, the Harvard Biomarker Study, Michael J. Fox's Parkinson's Progression Marker Initiative, includes Lewy body dementia cases and some of our clinical trial cases. And we have proteomics, transcriptomics from the blood, whole genome sequencing, and clinical data. And the proteomics comes from not just blood, but spinal fluid as well. So all this data is now in a data portal built by the Verily Corporation, an offshoot of Google. And we're looking for people who are interested in really mining this data. And we're also interested in working on what problems would the second phase of the AMP-PD project work on. Single cell analysis of brain neurons and glia, looking at inflammation in Parkinson's, looking at other biomarkers that may be useful in phase 2 studies to show that a drug is actually hitting a target or at least demonstrating proof of principle. These are the kind of things that certainly the industry folks and we are very interested in getting phase 2 trials going in Parkinson's. And we've mentioned in the past, and we're now about to release the first funding opportunities for the Ultra Rare Gene Therapy Network. This is led by Dr. Nina Shore, and the goal is to develop a group that's going to be working to get gene therapies into patients, particularly children, with really tragic, rare neurological disorders. We've certainly seen successes with spinal muscular atrophy, and we want to kind of accelerate that process of getting more diseases tested in terms of either antisense therapies to knock out a harmful gene or gene product, or actually replacing a mutation. So really looking forward to this kind of second, really exciting second phase, I think, in therapeutics for neurological disorders. In terms of treatments, there's a new program also that's coming out, and applications are due October 20th for the kind of the central organizing group that's going to be working to develop devices to treat neuroscience, clinical neuroscience problems. And this is a blueprint project, so it would cater to disorders in any of the neuroscience institutes at NIH who form this blueprint to coordinate neuroscience research. And then it has this phase which will be run by a Medtech translator working with groups to get their devices to the point where they can compete for larger funding that would go in, hopefully at the end, in a first-in-human study. So very similar to the Blueprint Neurotherapeutics program for small molecules or biologics. This one is for devices, and led heavily at NINDS by Nick Langos and colleagues from NIBIB. The BRAIN Initiative continues to amaze, and just a heads up that there's a tremendous body of work that's now published in bioRxives, soon to be published in a journal, from the BRAIN Initiative Cell Census, where they have done single cell work to identify cell types in the human, the non-human primate, and the mouse, but not only to develop cell types from transcriptomics, but also to get physiological data by patch clamping on the cells and then pulling out the RNA from the cell after you patch clamped it. And then also looking at morphology of the cells, and then actually looking at anterograde and retrograde tracing to get the connectomics for these cells. So this is the Google map of the brain in its first installment, the motor cortex, M1. And we expect this is going to be a real eye-opener and a tremendous body of work coming from this team of hundreds working in this BRAIN Initiative project, a tremendous team project. We're also in the BRAIN Initiative under the direction of John Nye looking at the next stage, which is a whole brain microconnectivity analysis project. There have been multiple workshops looking at different ways of developing a connectome map of the brain at different scales, going all the way from electron microscopy to X-ray CT, or light microscopy using expansion microscopy, which could be done in a mammalian brain at this point and give molecular information in a connectome type of map. So real exciting projects to come in the BRAIN Initiative in the ensuing years. In addition, the neuroethics group has met recently, and their topic was looking at the ethics of paying research participants, a common but controversial practice, maybe not as common as it should be, and paying attention to the fact that money does not cause undue influence, that it would affect informed consent. We might hear a little bit more about this in some of the grants that we're going to be talking about coming up in our closed session. A couple of things to mention about efforts to improve diversity in our workforce. The BRAIN Initiative now in its applications has a new requirement that applicants need to articulate strategies that advance a project's scientific and technical merit through inclusivity. So this is a requirement. If it's not in the applications, they don't get reviewed, and it is a scorable criteria. So an effort by the Brain Initiative folks to try and improve the diversity of people working in the Brain Initiative, which has really been tough to move, but hopefully we are seeing improvement, and this is another attempt to advance that. We also, NINDS, with a number of other institutes, put out a notice of special interest indicating our interest in getting applications from people who can bring diverse perspectives to the science. And again, as we mentioned in the past, at NINDS, our data indicate that the number of applicants from underrepresented minorities is extremely low, and we're doing everything we can to try to train and attract more people into our science. We do know that our success rates are really the same across all different groups, but our application rates are low. And so this is a notice to try to kind of move a couple more people to come into the NINDS fold. In the same vein, there's new requirements from NIH that all of the conference grants will include a plan to enhance diversity in the application. So this is very similar to what we saw in the Brain Initiative, but now this applies to conference grants. There's also a supplement I wanted to mention, and this is the Reintegration program. So this is a supplement to fund people who are pre-doctoral students or postdocs who are adversely affected by finding themselves in unsafe or discriminatory environments, and they have to move, which is a terrible thing because you can't really make up for that time lost. But there's a supplement program that would go to the PI that they move to help kind of get them moving again in their science with funding from the supplement program. This is also combined with a reentry supplement program for people who have been out of research for a while, potentially, developing, or taking care of family responsibilities and now want to come back. And this is a supplement program where they can get funding to actually come back into the lab and retool. NIH, I think we mentioned this in the past, but I wanted to just do it again, that NIH has a process for folks who feel that they have been harassed, sexually harassed or otherwise harassed, to make an allegation. And so there is a website where people can report harassment or other serious concerns, whether they occur at a meeting or whether they occur at their institution. And then NINDS will look into this and then work with the institution in which that person was an employee. The person alleged perpetrator is an employer, to work with their institution to try and understand if there is a serious issue that needs to be taken care of. And in a similar vein, at meetings, there are now guidelines that the meeting organizers need to put in place a code of conduct and develop mechanisms for reporting misconduct of attendees that are attending their meetings. I remember Ben Barris was very enthusiastic about NIH doing something about sexual harassment that occurs at scientific meetings. And so this is one step in that direction. But hopefully these little steps will prevent abuses, because people know that they are not going to get away with it. They're going to get reported. A couple of things to mention about our communications with our disease organizations. We held the nonprofit forum, a very successful meeting. Sam White, thanks to Sam's work, in July, we had 300 registrants, 200 participants, talked about a number of really important issues, clinical research during COVID, how kind of remote patient visits is actually working in some cases. We talked heavily about how to get more patient engagement in NIH research, tools and resources for nonprofits, and the importance of early diagnoses, particularly for these neurogenetic disorders. This is recorded, so if people want to go back and listen, please do so. And again, to mention, and hopefully we'll get a chance to see the trailer at the end, of a movie that Susan Snyder Williams was instrumental in putting out there about the trouble that Robin Williams had with Lewy body disease. He didn't know he had Lewy body disease, which was really part of the problem, and think may have led to his really early demise. But Susan is a really energetic and really forceful speaker for understanding more on Lewy body disease. In that regard, as I mentioned, NINDS manages about 10% of the money that came to the Aging Institute for Dementia Research. We manage research in frontotemporal dementia, vascular contributions to dementia, Lewy body dementia, not so much in Alzheimer's, but in these three we call Alzheimer-related dementias. And you can see here from the graph that over time, the amount of funding that we receive from the NIA to manage these programs has now dwarfed what we put in from our base budget. This money goes to solicited programs, RFAs, but also the pay line for research that comes in and is coded as Alzheimer's disease-related dementia. The pay line is now, last year was 28th percentile, which was twice as good as our regular pay line. So some of this is unsolicited research as well. And finally, I want to end up by mentioning, as I have in the past, that Richard Benson has been leading our strategic planning in advancing health equity in neurological disorders. And this will be coming to a climactic end in a really interesting workshop, September 22nd to September 24th, and one can still register for this. So with that, I want to thank everybody for your attention. Please, let's open it up for some questions, and if there's advice on, how to advance, better advance basic research or ARPA-H or any other things we talked about today, we'd be very interested in hearing about that. And with that, I'm going to start the trailer and see how much time we have.
Ladies and gentlemen, Robin Williams.
What's your brain doing when 10,000 people are laughing their heads off?
I'm not a tuna.
The human brain is, an extraordinary 3.5-pound gland. The moment you think you understand it, it comes out with something else.
The breaking news, actor Robin Williams is dead at the age of 63.
They believe that the Bay Area resident committed suicide.
There was a lot of media speculation.
On Robin Williams' mind before his death, money.
He's broke or he's depressed or he's just given up.
The last movie, it was clear to all of us on that set that something was going on with Robin.
There was something eroding within him.
I was called in to go over the coroner's report. It was the beginning of understanding what had really gone on. My husband had unknowingly been battling a deadly disease.
Lewy body dementia is a devastating illness, increases anxiety, self-doubt, causes delusions that have never been present in someone.
Nearly every region of his brain was under attack. He experienced himself disintegrating.
I remember him saying to me, I don't know what's going on, I'm not me anymore.
It really amazed me that Robin could walk or move at all. People who are incredibly brilliant can tolerate degenerative diseases better. Robin Williams was a genius.